Today we're going to cover section 5.3, rational and radical equations. So take the time to copy your title, your essential question, how do you use rational equations to solve work problems? Paste your cutout and copy example number 1. We'll start once you are ready. Go and pause it. A rational equation involves one or more rational expressions, makes sense, or at least one term having a variable expression raised to a negative integer power. So if you remember, another way to be able to write this expression, what happens when you have a negative exponent? You can bring it down to the denominator and we can say positive exponent, so therefore we have x minus 3. And because the exponent is 1, I don't need the 1 on the exponent, so therefore I don't need the parentheses. We have 1 on the numerator, and there is 7. In the same way that whenever you see 5 to the negative 1, that is the same thing as 1/5. So that's something that you should be comfortable with. When multiplying or dividing an equation by a variable expression, it is possible to introduce an extraneous solution. So this is something that you covered last year. What are extraneous solutions? It's a solution that does not satisfy the original equation. So you do everything perfectly on your problem, but then that will make the answer that you get will not satisfy your equation. So therefore, that is not a correct answer. So let's go through example number 1. How do we solve this? So there's two ways of thinking about this. I can place a 1 underneath the 1 to make that into a fraction, and then I can cross multiply. Or my purpose is to be able to cancel my denominator, so therefore I multiply both sides by 2x plus 1. So just like we covered last time, we want to get rid of the fractions right away. So therefore I multiply the left hand side by 2x plus 1 and the right hand side by 2x plus 1. So therefore the 2x plus 1 cancels on the left, that is gone. And the only thing that I have on the left is x plus 2. On the right, I can use my distributive property. Nothing cancels, so therefore 1 times 2x is 2x. 1 times 1 is 1. And now we just have a simple equation to solve. Move my x's to the left, my numbers to the right. So it gives me a negative 2x plus x is negative x minus 2, so it'll be a negative 1. So therefore x equals 1. But we have to be careful because we multiply by an x on both sides. So this might be an extraneous solution. So what we need to do, two different ways that we can think about it. We can double check what are our restrictions because we don't want the denominator to be 0. And we're going to call those our restrictions. 2x plus 1 cannot be equal to 0 because otherwise it'll be undefined. Move the 1 to the right, we can say negative. So therefore 2x cannot be equal to negative 1. X cannot be equal to negative 1/2. Is answer equal to negative 1/2? No. So that's correct. Another way to think about it is just to be able to decide whether this will make my denominator 0. And it doesn't. Another way, so therefore that's correct. Another way to think about it is we can actually just go through the process and check. Plug in a 1 into the x's and see if that gives you 1. Plug in 1 gives you 2. 1 plus 2 is 3. That gives you 2 plus 1 is 3. 3 divided by 3 is 1. But what I'll be doing is finding my restrictions and confirming that my denominator is not my restriction, will not make my denominator 0. So let's go through example number 2. Go ahead and copy it down and we'll start once you are ready. Go ahead and pause it. So for example number 2, I need to solve. We have fractions. So once again, we want to get rid of the fractions. I notice that I have a x squared minus 4 here, and I know that that can be factored. So one of the things that you want to do first is to factor out your denominators. So x minus 2 cannot be factored. X plus 2 cannot be factored. But I can factor. This is called the difference of two squares. x minus 2, x plus 2. And now I'm going to multiply by my lowest common multiple. I want this x minus 2 to cancel, so therefore I'll multiply by x minus 2. I want this x plus 2 to cancel, so x plus 2. I want this denominator to cancel, but they both already are here, so therefore that is my lowest common multiple. I'm going to multiply the left hand side and the right hand side by x minus 2, x plus 2, or I can just multiply each of the terms and I'll be doing that instead. So therefore, what cancels on the first one? X minus 2 cancels. So therefore I have x multiplied by x plus 2. On the next one, my x plus 2 cancels. So therefore I have a plus 1, x minus 2. And on the last one, they both cancel. So I have it equals 8. And now I can solve it. So use your destroyer property, solve it, and see what you get. And we can compare our answers afterwards. And pause it. So in this case, that gives me x squared plus 2x plus x minus 2 equals 8. Combine like terms. That gives me x squared plus 3x minus 2 equals 8. I have a quadratic equation. I want to make it equal to 0 to see if I can factor it. So move that 8 to the left. You can say negative 8, so it's negative 10 equals 0. And now I can factor this out. If I can't factor, can I complete the square? You can, but then this 3 is not even, so it makes it a little more challenging. So if I cannot factor, I'll be using my quadratic formula. But this factors nicely. So it gives me 5 and 2, positive and negative, and that works. And now x minus 2 equal to 0, so x equal to 2, or x equal to negative 5 by using my zero product property. Now I want to double check, do any of them make my denominator 0? I can do it two ways. I can find out my restrictions, and let's do that here, or I can just plug in and see if any of them make it 0. So let's go and do our restrictions. Restrictions. So therefore, I'm going to be looking at my lowest common multiple. What will make this 0? So we don't want x minus 2 to be 0. So therefore, x cannot be equal to 2, because that will make this denominator 0. Then x cannot be equal to negative 2 either. This is already taken care of by this one here, and that one's already taken care of this one. And notice I'm only focusing on the factor form instead of this one. Makes it a little bit easier. So therefore, this is not correct. This is called an extraneous solution. And negative 5 is not part of my restriction, so therefore that is correct. So extraneous solutions are solutions that you get when you multiply both sides by a variable. Let's go to example number 3. Go and write it down. And see if you can rewrite it without the negative exponent. See what you get. Go and pause it, and we'll start once you're ready. So in this case, my negative exponent belongs only to the x. Do you agree? So therefore, I have a negative 6 over x squared plus 4. The only that has the negative exponent is the x. That 4 has an exponent of 1. So therefore, that goes on the denominator. And now, once again, I want to get rid of, I want to cancel my denominators. That should be your first step. So therefore, I'm going to multiply by the lowest common multiple. I want to cancel both x's, so I'm going to multiply by xx or x squared. I want to cancel this x, but that's going to be already canceled with the first one, correct? So therefore, I'm going to multiply each one by x, 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 or x squared. In this case, they both cancel out. So now I have a negative 6 plus one of the x's cancel. So it'll be 4x equals negative x squared. So now we have a quadratic equation that we can solve. So go and pause it, solve it, and see what you get. Go and pause it. So in this case, I want to solve for x. I want to make it equal to 0. So I'll move my x squared to the left. We can say positive x squared plus 4x minus 6 equal to 0. Can I factor this out? No, this cannot be factored out. So either I can complete the square or use the quadratic formula. We have a leading coefficient of 1, and that's even, so therefore I'm going to complete the square. Move the 6 to the right, we can say positive 6, x squared plus 4x, leave some space, 6, and complete my square. One number goes in here. Half of 4 is 2, 2 times 2 is 4. I can factor this out, x plus 2 or x plus 2 square. So that's a perfect square trinomial. 10, square root on both sides, so therefore x plus 2 equals the square root of 10, but let me not forget my plus or minus. Move the 2 to the right, we can say negative 2. So therefore I have two answers, either x equal to negative 2 plus square root of 10, or x equal to negative 2 minus square root of 10. So now we have to be concerned whether any of those two answers will make my denominator 0. No, correct? My only restriction in here what value will make my denominator 0? 0. X cannot be equal to 0. So therefore, both of them are correct. And this is a very common question on your SPEC. Rate of work. Take the time to paste your cutout, copy example number 4, and we'll start once you are ready. Go ahead and pause it. If one task can be completed in X unit of time, then the rate of work is as follows. 1 over X, task per minute. So we have 1 over X, where 1 is the task. Now sometimes there will be 2 tasks or 3 tasks every hour. And this is the time unit. So something to keep in mind is that this is not always 1. It all depends how many tasks the person or the machine can complete in that specific amount of time. But let's go through example number 4. The setup is pretty easy. Many of you guys have not seen this before, so it can be a little bit challenging. It takes machine B 1 hour less to complete a task when working alone than it takes machine A working alone. If they start working together, they can complete the task in 72 minutes. How long does it take each machine to complete the task when working alone? You got it? Can you set up an equation? Do you remember seeing something like this before? So let's say machine B. For machine B, it takes 1 hour less to complete a task when working alone. So we have A versus B. So machine B takes 1 hour less than machine A. So let's go and let A be X, will be X hours, because we're talking about hours. Therefore, machine B takes 1 hour less, so therefore will be X minus 1 hours. If they start working together, they can complete the task in 72 minutes. So therefore, machine A, so we're going to set up our equation A and B. And are they working together or are they working against each other? So sometimes they're going to be working together, so there'll be a plus in between. Sometimes they're going to be working against each other, so there'll be a minus in between. In this case, they are working together, so it'll be a plus. Let me actually just write down below. Machine A, it takes X hours. How many tasks? 8 tasks. So therefore be 1 task every X hours. Machine A will get it done. Machine B, complete 8 tasks, and it will take it 1 hour less, so be X minus 1. If they start working together, so that'll be a plus, they can complete that task. How many tasks? 1. How long will it take? 72 minutes. Now I need this either as a decimal or as a fraction, whichever you prefer, in terms of hours. 72 minutes, I know it's 1 hour. And how many minutes? 12 minutes. So it'll be 1.12 minutes is 1/5 of an hour, so therefore it'll be 1.2. Or you can think about 72 over 60 minutes and divide by 12. This gives you 6, divided by 12 gives you 5, which is 1.2. Whichever way you prefer to think about it works well. So therefore, question, decimal or fraction? Which one do you prefer? Decimal? Perfect. Either one works fine. 1.2 hours. So it takes together, working together, it takes them 1 task, they'll complete it in 1.2 hours. And now we just need to solve for x. I want to cancel my denominator, so therefore I'm going to multiply each one by x minus 1, and 1.2. So multiply by 1.2, x minus 1. 1.2, x minus 1. So let's see. On the first one, what cancels? One of the x's cancels. So therefore, I have 1 times 1.2 times x minus 1 plus. On the next one, my x minus 1 cancels. So therefore, I have 1.2 x times 1. And on the last one, my 1.2 cancels. So therefore, I just have x times x minus 1. So go and solve it, see what you get, and then we can compare our answers. Go and pause it, solve it. So in this case, I'm just going to multiply it out, so I end up with 1.2x minus 1.2 plus 1.2x equals x squared minus x. Once again, we want to get rid of the decimals, so therefore I'm going to multiply everything by 10. The left and the right by 10. So therefore that gives me 12x minus 12 plus 12x equals 10x squared minus 10x. I want to make it equal to 0. I want to keep my x squared positive. So therefore I'm going to move everything to the right. I have 0 equals 10x squared. I'll move 12x, and 12x is 24x. We can say 34x, negative 34x. The 12 we can say positive 12. And now I'm going to factor it. If not, I can use the quadratic formula. So let's see, what can I factor out? I can factor a 2 from here, and what's left behind? 2 times 5x squared 2 times negative 17x, and 2 times positive 6. Remember that you always want to take out a common factor, because now I can see that this actually factors nicely. Does it? 5x and x. Factors of 6 will be 3 and 2, so that'll be 3, 15, and 2 here, and the both should be negative. Bring down my 2 equal to 0. And now I can solve it. 0 is equal to 2, false. 5x minus 2 equal to 0, or x minus 3 equal to 0. So therefore x equal to 2 over 5, or x equal to positive 3. Like I said, only one of them may be the answer, or both. Whenever you multiply by x, you might end up with extraneous solutions. So let's check. Machine A, machine B. Which one should we try first? Let's try the 3 first, so it'll be easier, right? So it'll be x hours, so it'll be 3 hours. So therefore, if that takes 3 hours, and machine B will do 1 less, will be 2 hours. So it'll be 3 minus 1, which will be 2 hours. Okay, so that one works fine. Now let's try 2/5. This will be 2 over 5 hours. And what's 2 over 5 minus 1? That'll be negative 3/5. So we cannot work negative, so therefore that is not correct. So the only answers is the machine A takes 3 hours to complete a task. And machine B takes 2 hours, 1 hour less. Together, they can complete it in 72 minutes. See if you can set up the next one. So very similar. Go ahead and pause it, read through it, solve it, and then we can check your answers. You got it? So let's see. Mike can wash 5 windows in 3 hours. David can wash a window in 3 hours. If they work together, how long will it take them to wash 3 windows? So let's see. We have Mike and we have David. Mike can wash 5 windows. Remember, it's the number of tasks, so 5. How long? 3 hours. Are they working together or against each other? They're working together, so be a plus. If they're working against each other, it will be a minus. David can wash a window, 1 window, in 3 hours. If they work together, how long will it take them to wash 3 windows? So 3 windows, how long will it take them? So remember, this is the number of tasks, and this is the time. And now we can solve it. So we can multiply everything by 3x. So the lowest common multiple will be 3x. So it'll be 3x, 3x, and 3x. So on the first one, the 3's cancel. So I end up with 5x. On the second one, the 3's cancel. So I end up with plus x. On the last one, the x cancel. So I end up with 9. So I'll give us 6x equals to 9. So therefore, x equal to 9 over 6. Reduce it by 3, so x equal to 3 over 2. So how long will it take them? Now remember that the only x that we have on the denominator is here. So x cannot be 0, which this one's fine. So it will take David will take 1.5 hours for David and Mike to wash how many windows? 3 windows. And now example number 6. We're going to go into radical equations. Go ahead and pause it, and we'll continue once you're ready. Go and paste your cutout and copy example number 6. So do you remember how to solve radical equations? Radical equations are equations that involve a radical. Now remember that whenever you have an exponent of 1/2, this is the same thing as the square root of x minus 3, where the 2 is the root that we don't write down if it's a 2, and the exponent is 1, so it'll be 1/2. When squaring each side of an equation or raising each side of an equation to a rational power, it is possible to introduce extraneous solutions. So every time you square on both sides, you might end up with an extraneous solutions once again. So we have extraneous solutions. So therefore, I have a radical equation. I want to get rid of the radical. So therefore, I'm going to move my x to the right. So therefore, I have 11 minus x equals, we can say positive x plus 1. And now, how can I get rid of the radical? How can I get rid of a square? By squaring both sides. Every time you square both sides, you might end up with an extraneous solution. So you have 11 minus x equals, what's x plus 1 squared? X squared plus 2x plus 1. And now we have an equation that we can solve. So make it equal to 0, solve it, and see what you get. Go and pause it. So I have 0 equals x squared. Move the x to the right, we can say positive, so it'll be 3x. Move the 11 to the right, we can say negative, so it'll be negative 10. And can we factor this out? X and x, 5 and 2, positive and negative. So therefore x equals 2, or x equal to negative 5. And the only way to check is just plugging it back in. So I need to check each one. So square root of 11 minus x equals 1. Remember, we want to make sure that we plug in into the original function. So it gives me square of 9 minus 2 is equal to 9. So it'll be 3 minus 2 equal to 1, 1 equal to 1. So therefore this one's correct. Let's check the 5. Check the 5 and see if that's correct or not. And pause it. So in this case we have 11 minus x equals 1. So that's a 5 and that's a 5. 11 minus 5 is 4, 6. Oh, it's negative 5, right? That's a negative 5. Here I was doing something wrong. So that's 11 plus 5 is 16. Square of 16 plus 5. That is 4 plus 5. Is it equal to 9? To 1? No. So therefore, 2 is the only correct answer. Example number 7. Last example for today. Go and copy it down, and then we can talk about what we can do. So in this case, there's different ways of solving this. I do want to get rid of the square or the square roots of the radicals. So I'm just going to move one of my square roots to the right. We have 2x plus 3 equals 1 plus the square root of x plus 1. And now I'm going to square both sides. So it's going to get a little bit more work. Now you could have done it up here, but then it'll be a little more challenging. I could just square both sides here. It'll still be fine. But let's go through the process. So in this case that cancels, so I end up with 2x plus 3 equals. Now remember that this is just like multiplying it twice. So let me rewrite it. 1 plus square root of x plus 1. Correct? And now we need to multiply. So multiply it out and see what you get. Go and pause it. So 1 times 1 is 1. 1, that gives me square of x plus 1. This gives me another square of x plus 1, so it gives me plus 2 square of x plus 1. And multiply this out, end up with x plus 1 times x plus 1. The square roots cancel, so I end up with x plus 1. And now I'm going to leave my square root by itself. I want to get rid of this too. Combine like terms. So therefore I end up with 2x plus 3. I'll combine like terms. 2 square of x plus 1 plus x plus 2. Minus x on both sides, end up with x. Minus 2 on both sides, end up with plus 1. I can divide by 2, or I can just square both sides at this point again. Remember that because we're squaring them, we might end up with an extraneous solution. So now we end up with x plus 1 squared is x squared plus 2x plus 1. Square gives me 4. The square root and the square cancel, so I end up with x plus 1. And now we can solve it. So make it equal to 0, solve it, see what you get. X squared plus 2x plus 1, 4x plus 4. Move everything to the left. Minus 2x minus 3. And hopefully this factors, otherwise I'm going to complete the square. X and x, 3 and 1, negative and positive. And we are done. We're not done, right? Because we might end up with an extraneous solution, so we need to check each one, and we need to check into the original problem. So let's go and check the first one. Is negative 1 a solution? Go and check it and see what you get. Let's see. Square root of 2x plus 3 minus square root of x plus 1 equal to 1, where my x is negative 1. So I end up with negative 2 plus 3 is square root of 1 minus square root of 0 equals to 1. Is 1 minus 0 equal to 1? 1 equal to 1? Yes. So negative 1 is the correct solution. 3 might be a solution, might not. So check 3 to see if it's a correct solution. Then pause it. Let's see. Square root of 2x plus 3 minus plus 1 equal to 1. And we'll plug in a 3. It's a very quick process. 6 9ths, square root of 9 minus square root of 4. So it gives me 3 minus 2. Is that equal to 1? Yes. So they both are correct. So therefore x equals negative 1, comma 3. Remember that this is a set notation and it's not a point. So that will conclude the lesson for today. Have a great day and I'll see you guys next time.